Welcome back. In this video, we're going to start chapter 5, which is on systems of linear equations. As always, when we start a chapter, it's a good idea to look ahead and see what it is we're getting into before we get into it. So this chapter has a total of 6 sections. We're only going to do the first 5, as those are the ones that are most relevant to us. So 5, systems of linear equations. 5.1, it says solve systems of equations by graphing. Then 2, systems of equations by substitution, then by elimination. So we need to know what a system of equations is. Once we know what that is, in the first section, we solve them by graphing. The second section, we solve them by substitution, and then by elimination. So once we know what a system of equations is, we learn a couple of different ways of solving them. In section 5.4, it says solve applications with systems of equations. So this will be word problems where we use a system of equations to solve. And then 5.5, solve mixture applications specifically. So the last 2 sections are about story problems. The first 3 sections are about how you solve a system of equations using a couple of different methods. So section 5.1 by graphing, and this also covers just what exactly a system of equations is. So here we'll get started then on 5.1. A linear system of equations is when several linear equations are grouped together, like you see here, 3x minus y equals 7, and x minus 2y equals 4. A solution of a system of linear equations is an ordered pair. It's not just a single number. So you'll have a pair corresponding to a value for x, and y in this case. When you write down the pair, the x always goes on the left and the y goes on the right. And throughout this chapter, it says systems of linear equations. We'll be looking at systems of 2 equations and 2 unknowns. So we'll have just 2 variables. So solutions, like I said, are ordered pairs. And we want to next decide whether each of these pairs, 1, -3, and then 0, 0, if they make up solutions to the system given here, 3x plus y equals 0 and x plus 2y equals -5. I forgot to write a little curly brace, so let me put it on there. Usually we use a little curly brace just on the left to show that those couple equations belong together somehow. All right, so let's decide if each of these pairs makes up a solution to that system. To be a solution, the xy pair has to satisfy both equations. So let's try 3x plus y equals 0. 3 times 1 plus -3. We want to know if that equals 0. 3 plus -3 does in fact equal 0. So that pair fit the first equation. Let's check the second equation. 1 plus 2 times -3, that can equal -5. 1 minus 5, or plus -5 if you want, equals -5. Sorry, I got a step ahead of myself. 2 times -3 is -6. So that's 1 minus 6. I wrote the -5 because I'd calculated it. 1 minus 6 is -5. -5 is -5, so that works. This pair of xy values satisfies both equations, and so the answer is yes. That would be a solution to that system of equations. Let's try 0, 0. 3 times 0 plus 0, is that equal to 0? And yes, it's true that it fits that first equation. How about the second one? It has to fit both in order to be a solution. Here we have 0 equals -5, and that's no. It would have to satisfy both of the equations. It could fit one, but it has to fit both in order to be a solution to the system. So the first pair, 1, -3, was a solution. The second pair, 0, 0, was not a solution to 3x plus y equals 0, x plus 2y equals -5. Okay, there's a couple of different methods for finding these solutions. If I give you this couple equations, how do you go about finding what xy pair fits that? One method is by graphing. And how that works is to recognize that 3x plus y equals 0, that would be the equation of a line. And then x plus 2y equals -5, that's also the equation of a line. If we graph those two, we might be able to see the solution. If you graph the two lines, only one of a couple things can happen. The two lines might intersect in a single point. If so, there's just one solution. It may be that the two lines don't intersect at all, in which case there's no solution. Or it could be that the two lines, their graphs would lie exactly on top of each other, in which case there are infinitely many solutions. So there's three different possibilities: one solution, no solutions, or infinitely many solutions. You'll never have like exactly two solutions for this. It's either one, none, or many. Okay. By the way, systems of linear equations can have more equations, more variables, and also be nonlinear equations. But in our class, our work right now, we're just working with two equations, two variables, and they'll always be linear. Okay, but keep in mind that that's possible for the future, so that I don't have to keep saying linear system of equations in two equations and two unknowns every time I say it. So linear system could be a lot of things. For us, it's going to be two equations, two variables, both linear. Okay, so how to solve one of these systems by graphing. So the good news and bad news. The good news is that the directions are really simple. Graph both lines and see if they cross someplace. If they cross someplace, where they cross is your answer. The bad news is if you don't like graphing, you're not going to like this very much. So we'll do the best we can with it. So here we have x minus 3y is negative 3 and x plus y equals 5. So here our two equations are in general form, so it makes sense for me to try to use the intercepts to graph this. So the one on the left, if x is 0, it looks like y will be 1. And if y were 0, it looks like x would be negative 3. Okay, so 0, 1, and negative 3, 0. Okay, that's going to be our first equation. You may want to practice that finding of intercepts if you're a little rusty on it. For the second one, when okay, sorry about that. Zoom crashed on me again. So for the second equation, x plus y equals 5. When x is 0, y is 5. And when x is 5, y is 0. So this will give us our two intercepts, 0, 5, and 5, 0. Okay, it looks like the two lines cross right here at the point 3, 2. So 3, 2 is going to be our solution. Notice that it is an ordered pair. Okay, and that's always true on these. Okay, so that's how this goes. You graph the line, you graph the other line, you look and see where they cross. Wherever they cross makes up the solution. Okay, let's try the next one. The next two lines are in slope-intercept form, so we can use the slope and y-intercept to graph. So let's do that. The first one, I'm going to color that one green. This one has a y-intercept of 2 and a slope of 2. So I will go up 2 and right 1 to make another point on the line. I guess a little more good news is that you're going to get extra practice at graphing doing this. Okay, so there's that. And then let's go purple for the other one. The other one has a y-intercept of negative 4 and a slope of negative 1. So I can go down 1 and right 1. Make the second one. Okay, now this one, it kind of illustrates how, like, a disadvantage of doing the graphing method, because here it didn't, the way I drew it at least, it didn't look like it landed right on where that point crossed. It could be that the solution is like negative 1.9, negative 2.1, something like that. But it's possible also that I just didn't graph very carefully. But it looks like it probably is supposed to be negative 2, 2. If I graphed more carefully, negative 2, negative 2. If I graphed a little more carefully, maybe that would have been it. Now that I have a guess, though, I'm going to plug that into the system of equations and see if that works. So let's do that. For the first one, our y would have been -2. We'll have 2 times -2 plus 2. So -2 is -4 plus 2. That's true. For the second one, -2 is -2 minus 4. -2 is 2 minus 4. -2 is -2. So that actually worked. So plugging in the -2, it showed me that that was going to work. I can tell that this won't be that infinitely many solution case because the two lines aren't coincident, judging by their graphs. Like I said, that does illustrate one of the downsides of the graphing method for solving a system of equations. For one, as you see, it's time consuming to have to draw the lines. And for two, you have to be really careful how you do your drawing. And here the equations themselves are not that bad. All right, let's try a couple of more. Here, y equals 2. That is a horizontal line, right? It has y-intercept of 2. And then x plus 3y equals 6. Let me find intercepts for that one. When x is 0, y will be 2. When y is 0, x will be 6. So 0, 2. I guess that's our solution, isn't it? And then 6, 0. Okay. All right. This one, it just so happens that the point of intersection of the two lines was the y-intercept of our pink line. So the solution looks like it's 0, 2. Okay. All right, let's solve one more by graphing. This time, why don't you pause the video and try it yourself, and then restart the video and see how you did. Okay, so the first one is in slope-intercept form, so I'm going to use the slope and intercept to graph it. The y-intercept is 2, and the slope is -1/4. So I can go down 1 and right 4. That looks like a good choice. I'll go down 1 and right 4. I could have gone up 1 and left 4, though, right? Let me actually do that. Maybe that'll help make my graph better. Up 1 and left 4. Okay, all 3 of those points should be on the line. A little tricky to get that just right. Okay, well, hopefully that will do. Let's see. Now for the second one is in general form, so let me use intercepts. When x is 0, it looks like y will be -2. When y is 0, it looks like x is -8. So we have -8, 0, and 0, -2. This one, it doesn't look like they're going to cross unless it does like way off the edge of the screen here. I'm betting these guys are parallel. Sorry, that one was really off the dots. Let's make that a little better. Okay, those two, it looks like they're parallel unless, like I said, they intersect somewhere like miles away. But how I can check is I'll take that second equation and rewrite it in slope-intercept form and see if the slopes match. So we'll have 4y equals -x minus 8. Then y is -1/4 x minus 2. Okay, so putting that in slope-intercept form, we can see that the slope was also -1/4. So the two lines are parallel. That means that there's just no solution. Okay, you can write out the words "no solution." You could write out the empty set as either like a kind of a rounded off 0 with a slash through it, or a pair of curly braces with nothing inside. If you're doing like an online homework system, sometimes they have like a multiple choice here where you'd enter the answer if there is one, and one option you can check says no solution. So it depends on how you're doing your homework, how to answer questions like that. Okay, if the two lines when we graphed them had been right on top of each other, that would have been the infinitely many solutions case. All right, that takes us to the end of this video and this section really on systems of linear equations. We've seen that a system of linear equations in two variables is basically just a grouping or putting together of two equations. A solution to such a system is a pair xy that fits both of those equations. Some of the things that we can do is plug in a given xy pair to see if it is a solution. Other than that, the method we've seen so far to solve a system is by graphing both the lines and seeing if they cross someplace. Wherever they cross is your answer. If they don't cross at all, there's no solution. If the two lines are just on top of each other, then there are infinitely many solutions. In the next section, we're going to see a more practical method of solving these systems using substitution, and that won't have that advantage or disadvantage of needing to be so careful about graphing, and will be a little bit less time consuming. Okay, but until then, that's the end. Let me know if you have any questions, and have a great day.